Hi guys, today we'll see recursion. What are the recursion methods? And we'll see some examples for recursion. So let us understand how we can write programs with recursion. And before understanding that, so recursion is what? When a function call itself. So let us say you are defining one function and in that you are calling the same function. So we can say it is a recursive function. So that is in the course of the function definition, there is a call to that very same function, right? So at first, this may seem like a never ending loop. So if you have not have a good control on the recursive functions, it may be infinite loop. So it is like a dog chasing its tail and it can never catch it. So to it seems our method will never finish. This might be true in some cases, but in practice we can check to see if a certain condition is true and in that case method is get exit. So the case in which we end our recursion is called a base case. So we have to find what is the base case in my program when we are writing the recursion function. So this is very important to understand the base case first of all. And additionally, just as in loop, we must change some value and incrementally advance closer to our base case. So that we have to take care when we're writing that program. Okay, so let us have one sample here. Now let us we want to find one factorial. So factorial of n. If I pass any number, it will return me the factorial of that function. Okay, so consider I have a function here. What? It's a factorial function, and this factorial function is calling again here, right? So this factorial is getting invoked by same factorial method. So here I have n and here we are passing n minus 1. But look at this condition. So here I have one condition that if n equal to 1, return 1. So in this case, the function will get written. As the value of n becomes 1, it will be written and give you the return. So we can say this is my base case at which function will come out. Okay, and so we can see like we already know that n factorial means what. If someone asks 5 factorial, so 5 into 4 into 3 into 2 into 1, right? So what happened in the case of that example? If we are calling, let us say factorial 5, so it is calling factorial 5 and then it is calling factorial 4, then 3, then 2, then 1. So as it's become 1, it come out, right? So that is my base case. Okay, if n equal to 1, then return 1. So as the base case reaches here, now we're getting the value 2. So now 2 into 3, so 6, 6 into 4, so 24, 24 into 5, so 120. So this is my output of my code, right? So basically the base case returns a value without making any subsequent recursive calls. Okay, so it does this for one or more special input values for which the functions can be evaluated without recursion. For factorial, the base case is n equal to 1. Okay, so in this code, base case is what? N equal to 1. Let us understand the basic flow. If you're writing some recursive functions, what you have to take care. Every recursion should have the following code flow characteristics. What? First, it should have one simple base case which we have a solution for and a return value. So this is very important now. A way of getting a problem closer to the base case, that is a way to chop out part of the problem to get a somewhat simpler problems. Okay, another characteristic is a recursive call which will passes the simpler problem back into the method. So this is another. Okay, so that's three characteristics we have to take care when we are solving some problem related to the recursion. So the key to thinking recursive is to see the solution to the problem as a smaller version of the same problem. So we can write recursion functions. The key to solving recursive programming requirements is to imagine that your method does what its name says. It does even before you have actually finished writing it. You must pretend the method does its job and then use it to solve the more complex cases. Okay. So if you can look this code here. So suppose we are having my factorial one integer, if integer equal to 1, return 1 else. Okay, do this process. So return integer my factorial integer minus 1. So this my factorial is a recursive here. So the same name keep calling here. So what I mean here, so if you look this code or this method, so here again it has been invoked. Once the integer is getting minus, so it will become 1, it will reach to some point where this base case meets and it will come out from the recursion method. Okay, look at this example here, the complete factorial examples. So here what we have done, we have made one recursive function, or the recursive function name is what? My factorial, calling here. Now it is in the same class. So this is my main method where I am trying to create object of this class and then calling here. So this recursive method, I just pass 5. So 5 is coming here. Now it is returning me 120. So this f is getting stored 120, and now I'm displaying here factorial of 5 is 120. So 120 will come here, right? So output we are getting here 120. Now first time I have passed 5, so it is checking here if integer equal to 1. No, it's a 5, so it will not come. So it will come to the else part, and then again we are saying 5 into 5 minus 1, so it is 4. So again it will 4. So it will keep passing like that, and once it becomes 1, so it will come out from the our recursive methods. Okay. Next, factorial flow. Look at this flow here. So again we are having one recursive function. So we are calling that recursive function here. Here the code is a little different. So look at here what we have to do here, that uh, the recursive method name is what? rec, right? So here we have to call rec, right? So I have to write here obj dot. So suppose this is obj dot rec, and then we have to pass say 5. Okay. So consider this is the code int f equal to obj dot rec 5. So we are passing here 5 now, and this will go to the my rec recursive function. So 5 will come here, right? Now it will get inside that and checking the condition not matching. So it will again call this recursive function with xman. So look at this flow. This main method is calling here, right? In turn, this recursive is getting called here, and again this recursive is getting called. So again once getting invoked here, right? Again it is calling, and so it is like this. So this is a flow here, right? And now once it is matching the condition, returning back to the previous call, again returning back to the previous call, returning back to the previous call, and finally coming to main. So it is returning f here. So whatever the resultant value after getting multiplication, it is returning and storing to f here, right? So we are printing a factorial of 5 is f. So it is 120. Another example I have for generating Fibonacci series. Okay, through recursion. So in that case, the recursive method has to display the values. So and that is the only way to generate the series and all. So if we talk about here, we are having few variables like uh, initial value, final value, and count. So initial values currently it is a 0. Okay, it is 0 here, and final value is what? It is 1, and count is 10. So I have to generate 10 Fibonacci's values. So here it is a 5 or 10 values are coming here. So all these three we have passed to the recursive function, and that recursive function is a Fibo generate. There's a one temporary variable, so int temp and then int count greater than 0. Here we are saying system on plan initial value. So what is the initial value? It is first time it is 0, right? So it is displaying here 0 now. So 0 is coming, and then we are doing what? Initial value plus final value. So 0 plus 1, it is becoming 1. So temp is getting 1 now. Initial value equal to final value. So final value is also 1. Initial value is becoming 1 again now, right? And final value equal to temp. So final value is having again 1 because temp was having 1, right? Count is decreasing. Count was 10, so now it is 9. And here we are saying fuse generate. Again we are calling here. So we are passing again 1, and here we are passing 1, and then we are passing what? 10. So earlier it was 0 0. Sorry, this final value was 1, right? So and count was 10. So this was 1 and this was 10, right? But at this time count will be what? Here it will be 9. So next time it is 1 plus 1 2, 2 will display, right? So but before before displaying 2, it is a 1 will display first. So again 1 is coming here, right? And my count will keep decreasing. So the time will come where count will be less than or like 0. So in that condition will fail, and last value will get displayed and come out from the recursion. So by this way we can generate series through recursion. Okay. How to write? So basic steps of recursive programs. Every recursive program follows the same basic sequence of steps. Initialize the algorithm. Recursive programs often need a seed value to start with, means some starting value where it will start, And this is accomplished either by using a parameter passed to the function or by providing gateway function that is a non-recursive but that sets up the seed values for the recursive calculation. So you need some starting values, you have to pass it, else you can pass it inside that. So check to see whether the current values being processed match the base case. If so, process and return the value. And then redefine the answer in terms of smaller or sub-problem of sub-programs. And finally, run the algorithm on the sub-problem. Combine the results in the formulation of the answer and return the results. So that you have to follow the steps for writing that. So look at here. Some review regarding the recursion is a great art, enabling programs for which it is easy to verify correctness without sacrificing performance, but it requires the programmers to look at programming in a new light. Imperative programming is often a more natural and intuitive starting place for new programmers, which is why most programming introduction focus on imperative language and methods. But as programs become more complex, recursive programming gives the programmer a better way of organizing code in a way that is both maintainable and logically consistent. So you will get a good idea to write this program